video, we introduced Euler paths and circuits. In this video, we'll continue our discussion on these concepts. If a graph has an Euler path and two vertices with odd degree, then the Euler path must start at one of the odd degree vertices and end at the other. In such a situation, every other vertex must have an even degree, since we need an equal number of edges to get to those vertices as to leave them. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below, and make sure to click on that subscribe button. How could we have an Euler circuit? The graph could not have any odd degree vertex, as an Euler path would have to start there or end there, but not both. Thus, for a graph to have an Euler circuit, all vertices must have even degree. The converse is also true though. If all of the vertices of a graph have even degree, then the graph has an Euler circuit, and if there are exactly two vertices with odd degree, the graph has an Euler path. To prove this is a little tricky, but the basic idea is that you'll never get stuck because there is an outbound edge for every inbound edge at every vertex. If you try to make an Euler path and miss some edges, you'll always be able to splice a circuit using the edges you previously missed. All right, let's take a look. Euler paths and circuits. A graph has an Euler circuit if and only if the degree of every vertex is even, and a graph has an Euler path if and only if there are at most two vertices with odd degree. Now, since the bridges of Königsberg graph have all four vertices with odd degree, there is no Euler path through the graph. Thus, there is no way for the townspeople to cross every bridge exactly once. Anyways, thanks everyone, and I'll see you in the next video.